Yellowstone National Park could be sitting on a time bomb. There is a supervolcano underneath the national treasure.
What happens beneath us is far scarier than science can comprehend. History has given us a small hint as to the ticking time bomb, which is Earth in general, and the beautiful, rocky, and breathtaking site, Yellowstone Park in particular. Against the captivating view of this park, the National Park Service does not have a good word for it. This is because Yellowstone has the most active, diverse, and intact collections of combined geothermal features, with over 15,000 hydrothermal sites and half the world's active geysers. And as is common knowledge, when the pressure rapidly drops in a localized spot, it actually forces the hot water to quickly turn to steam. Since gas takes up more space than liquid, the event of water turning to steam triggers a hydrothermal explosion like the one experienced in Yellowstone Park on Tuesday, 23rd of July, 2024. Is there more to this than meets the eye? Is the surreal park caving in on itself? Here is what we found out. Seismic activity in Yellowstone. Yellowstone National Park is located over a volcanic hotspot where magma from deep beneath the Earth's surface heats up groundwater, producing steam and causing the ground to shake. This unique geology makes Yellowstone one of the most seismically active places on the planet. The park experiences a high frequency of earthquakes, with around 1,000 to 2,500 quakes occurring annually, although most are too small to be felt by humans. These earthquakes are often described as a gentle hum of seismic activity, a reminder of the dynamic forces shaping the park's landscape. The seismic activity in Yellowstone is not limited to earthquakes. The park also experiences ground deformation, where the surface of the Earth rises or falls due to movement beneath the surface. This can be caused by the injection of magma into the crust or the movement of fluids through the rock. By monitoring ground deformation, scientists can gain insights into the park's volcanic system and better understand the forces driving seismic activity. In addition to earthquakes and ground deformation, Yellowstone also experiences tremors, which are small, continuous vibrations in the Earth's surface. These tremors can be caused by the movement of magma or fluids beneath the surface and can provide valuable insights into the park's volcanic activity. Geological history of Yellowstone. Yellowstone's geological history is marked by periods of intense volcanic activity, including the formation of the park's iconic caldera. This history provides valuable context for understanding the park's current seismic activity and the potential for future earthquakes. The caldera forming eruption that occurred 640,000 years ago was a pivotal event in Yellowstone's geological history. This eruption had a profound impact on the park's geology and set the stage for the current volcanic system. Yellowstone's geological history is also marked by periods of relative quiet, during which the park's volcanic system was less active. Understanding these periods of quiet can provide valuable insights into the park's long-term behavior and the potential for future seismic activity. Earthquake-triggered landslides. Earthquakes in Yellowstone can trigger landslides, which can have devastating consequences. Scientists are working to understand the mechanisms behind earthquake-triggered landslides and develop strategies for mitigating these risks. Researchers have identified areas within Yellowstone that are prone to landslide activity. These areas are being closely monitored, and scientists are working with park officials to develop strategies for mitigating the risks associated with landslides. In addition to landslides, earthquakes in Yellowstone can also trigger other secondary hazards, such as floods and debris flows. Scientists are working to understand the mechanisms behind these hazards and develop strategies for mitigating their impacts. Hydrothermal activity and earthquakes. Hydrothermal activity, such as hot springs and geysers, is closely linked to Yellowstone's seismic activity. Understanding the relationships between hydrothermal activity and earthquakes can provide valuable insights into the park's volcanic system. scientists have discovered that changes in hydrothermal activity can trigger earthquakes in Yellowstone. This is because hydrothermal fluids can alter the stress on the surrounding rock, making it more prone to failure. In addition to triggering earthquakes, hydrothermal activity can also influence the park's volcanic behavior. Scientists are working to understand the mechanisms behind this influence and develop strategies for predicting potential hazards. However, it is not entirely possible to totally understand a phenomenon as old as time. That is why the recent hydrothermal explosion, according to some scientists, was not foreseen and is most likely the first of many explosions to come. Causes of earthquakes in Yellowstone. The causes of Yellowstone's earthquakes are complex and multifaceted. The movement of magma and fluids beneath the surface plays a significant role, as does the cooling and contraction of the Earth's crust. The park's volcanic hotspot, where a mantle plume feeds magma into the crust, is a key driver of seismic activity. As magma moves and interacts with the surrounding rock, it can cause the ground to shake, resulting in earthquakes. Additionally, the park's unique geology, with its complex interplay of faults, fissures, and volcanic structures, contributes to the frequency and diversity of earthquakes. The movement of magma and fluids beneath Yellowstone's surface is a key factor in the park's seismic activity. As magma rises through the crust, it can cause the surrounding rock to fracture and release energy in the form of earthquakes. The movement of fluids, such as groundwater and hydrothermal fluids, can also cause earthquakes by altering the stress on the surrounding rock. Yellowstone's unique geology, with its complex interplay of faults, fissures, and volcanic structures, also plays a significant role in the park's seismic activity. The park's faults and fissures can act as conduits for magma and fluids, allowing them to move more easily through the crust and increasing the likelihood of earthquakes. Earthquake swarms in Yellowstone. Yellowstone often experiences earthquake swarms, where multiple quakes occur in a short period, often in the same general area. These swarms can be intense, with dozens or even hundreds of quakes occurring over several days or weeks. While most earthquakes in Yellowstone are small, with magnitudes less than 3.0, larger quakes can and do occur. The 1959 Hebgen Lake earthquake, which had a magnitude of 7.2, and the 1975 Norris earthquake, with a magnitude of 6.1, are examples of more significant seismic events in the park's recent history. Earthquake swarms in Yellowstone can be caused by a variety of factors, including the movement of magma and fluids beneath the surface. These swarms can also be triggered by changes in the stress on the surrounding rock, such as those caused by the injection of magma into the crust. In addition to providing insights into the park's volcanic system, earthquake swarms in Yellowstone can also have significant impacts on the environment. Changes in groundwater flow patterns, altered distribution of plants and animals, and increased risk of landslides are all potential consequences of earthquake swarms in the park. Monitoring seismic activity. The United States Geological Survey, USGS, closely monitors Yellowstone's seismic activity through a network of seismometers and ground deformation instruments. This monitoring system provides critical insights into the park's dynamic geology, helping scientists understand the complex interplay of forces shaping the landscape. By tracking earthquakes, ground deformation, and other indicators, the USGS and Yellowstone National Park officials can better understand the park's volcanic system and prepare for potential hazards. The USGS uses a variety of techniques to monitor seismic activity in Yellowstone, including seismometers, tilt meters, and GPS instruments. These instruments provide real-time data on earthquakes, ground deformation, and other changes in the park's geology. In addition to monitoring seismic activity, the USGS also conducts research into the park's volcanic system. This research helps scientists understand the underlying causes of seismic activity and better prepare for potential hazards. Understanding volcanic unrest. While earthquakes can be a sign of volcanic unrest, not all earthquakes indicate an impending eruption. Yellowstone's unique geology means that seismic activity will continue to occur, and the park's monitoring systems help scientists distinguish between normal background activity and more significant events. the likelihood of a major earthquake, or, although Yellowstone's seismic activity is closely monitored, the possibility of a new earthquake cannot be ruled out. In fact, the USGS estimates that there is a 1 in 730 chance of a magnitude 7 or greater earthquake occurring in the Yellowstone region within the next few years. This highlights the importance of continued monitoring and research into the park's volcanic system. Areas of concern. Some areas within Yellowstone are of particular concern for potential earthquake activity. The Hebgen Lake Fault, which ruptured in 1959, is considered active and could potentially produce another significant earthquake. Additionally, the Norris Geyser Basin has experienced increased seismicity in recent years, suggesting that magma or fluids are moving beneath the surface. Ongoing monitoring of these areas is crucial for understanding the park's dynamic geology. While scientists can identify areas of increased seismicity, predicting the exact timing and location of a future earthquake is impossible. Therefore, it is essential for Yellowstone National Park officials and surrounding communities to be prepared for the unexpected. This includes having emergency response plans in place, conducting regular drills and training exercises, and maintaining open communication channels with the public. By being prepared, we can minimize the risks associated with earthquakes and ensure public safety. New research and findings. Recent studies have shed light on the complex dynamics of Yellowstone's volcanic system. Researchers have discovered new insights into the park's magma chamber, fault lines, and groundwater flow patterns. These findings help scientists better understand the underlying causes of seismic activity and improve their ability to predict potential hazards. Advances in geophysical imaging have allowed scientists to create detailed maps of Yellowstone's subsurface geology. This information helps researchers identify areas of increased seismic risk and better understand the park's volcanic system. New research has also focused on the role of groundwater in Yellowstone's seismic activity. Scientists have discovered that changes in groundwater flow patterns can trigger earthquakes and influence the park's volcanic behavior. Impacts on local communities. Earthquakes in Yellowstone can have significant impacts on local communities, including damage to infrastructure, disruptions to tourism, and risks to public safety. Understanding these impacts is essential for developing effective emergency response plans and mitigating the effects of seismic activity. Local communities surrounding Yellowstone are working closely with scientists and emergency responders to prepare for potential earthquakes. This includes developing evacuation plans, conducting regular drills, and establishing communication networks. The economic impacts of earthquakes in Yellowstone can be significant, particularly for the tourism industry. Scientists are working with local businesses to develop strategies for mitigating these impacts and ensuring the long-term sustainability of the regional economy. The systems of seismic activities in Yellowstone Park cannot be totally determined. However, geologists and other scientists are in the process of getting ahead of any future eruptions, taking cue from the recent hydrothermal eruption. Till then, Yellowstone is practically a time bomb with an indefinite detonation time. That's all we can take on today's video. Do let us know what you think about Yellowstone Park and the recent seismic events in the comment section below. Don't forget to like this video and subscribe to this channel for more amazing content. See you in the next video.